Hello and welcome to week 6 in geometry. At this time, please make sure you've got your math notebook out. We're going to start using our math notebook with a couple warm-up problems, and then you're going to continue to use your math notebook as you take notes as you watch this recording. So we are working in our probability unit, and the two warm-up questions are probability-based questions. So let's imagine we've got a bag full of marbles. And in that bag, there are 2 red marbles, there are 3 green marbles, there are 3 orange and 2 purple marbles. So based on that information, the first question you are going to answer is, what is the probability of choosing a green marble? And then, is this an example of experimental or theoretical probability? So go ahead and click pause, answer these 2 questions on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so the first question we were asked was to find the probability of choosing a green marble. So just a reminder of the notation that we've been using for probability. So if I were going to write this in probability notation, I would use a capital P, and then I'm just going to put green. I don't have to put green marble. If you want to, you can, but what is the probability? This means what's the probability of finding or choosing a green marble? So to find that probability, how many green marbles can we choose from? Well, there's 3 in our bag, so we can choose 3, and then what is the total number of marbles we're choosing from, which is the total number of outcomes that we can have? Well, there was 10 marbles, so it would be 3 out of 10. So remember, we can write probability as a fraction. We could leave it as 3/10. Or we can write it as a decimal, and if we did that, that would just be 0.3. Or we can write it as a percentage, move our decimal 2 places to the right and get 30%. So just a reminder that we can write probability as fraction, decimal, or percentage, and that's a 0.3. That kind of got weird looking there. All right, and then is that an example of experimental or theoretical? Well, remember, experimental is based on a number of trials or experiments, and there's none of that. We didn't collect any data here. We didn't choose a marble, write it down, choose another one, write it down. So this is purely based on what we expect to happen. So this is an example of theoretical probability. Okay, so let's look at what we will be focusing on this week. So this week we only have 1 session that we are going to do due to the shorter week, and that is Unit 6, Session 2, where we're going to be looking at independent events and finding the probability of independent and dependent events. So due to the shorter amount of work this week, it's a great week to get caught up if you do so need to. All right, so let's move on and take a look at what are independent and dependent events. So before we do, let's talk about what these vocab terms mean. So dependent events are when one event affects the probability of another event. So the events are dependent on one another. One event will affect the probability of another event. A lot of times you'll see examples of dependent events when you reach into a bag of marbles and you pull out a marble and then you do not put that marble back and you choose another one. So that would be those events. That second event depends on the first event, because if we were looking at our warm-up, we started with 10 marbles. Well, if we pull one marble out and we hold on to it and then we're asking about the probability of another event, we're only choosing from 9 marbles now. So that second event affects the first. Another example would be picking a card from a deck and not putting it back. So not replacing something is a good example of where we can get dependent events. Whereas independent events occur when one event has no impact or influence on another event. An example would be rolling a dice and then picking a card from a deck of cards. Neither of these events affect the other. Rolling a dice and picking a card are two totally different things. So these would be independent events. One event has no impact or influence on the other event. So we're going to look at how we go about finding the probability of each of these types of events. So let's start with independent events where one event does not affect the outcome of another event. So we already talked about what independent events are. So how do we find the probability of independent events? So if we have event A and event B, so we'll talk about event A and event B, and they are both independent events, meaning neither event has an outcome, affects the outcome of the other event, then the probability of both events occurring, so let's say we want to find the probability of both event A and B occurring, we will do that by finding the product. Product, remember, means when we multiply two things together of the probabilities of each individual event. So what we're going to do, if we want to find the probability of event A and B occurring, and they are both independent events, so we want to find the probability of A and B, what we're going to do is we're going to find the probability of just event A, and we're going to multiply that times the probability of event B occurring. So let's take a look at an example. It always makes a lot more sense when we start actually applying what we're learning to an actual example. So down at the bottom, we've got an example. We've got a drawer containing 3 red paper clips, 4 green paper clips, and 5 blue paper clips. So 3 red, 4 green, 5 blue. One paper clip is taken from the drawer and then replaced. So we're putting it back. We're not changing the number of total outcomes. Another paper clip is taken from that same drawer. So we want to find the probability that the first paper clip is red and the second paper clip is blue. All right, so let's write that in proper probability notation. So we want to find the probability of getting a red and a blue paper clip. So in order to do that, we're first going to find the probability of just choosing a red one. And we're going to multiply that times the probability of choosing a blue one. So what is, I'm going to continue down here, the probability of choosing a red paper clip? How many red paper clips are there? Looks like there's 3 out of the total number. So we've got 3 plus 4 is 7 plus 5. 3 plus 4 is 7 plus 5. Make sure I had right there with the number. So that is a total of 12, right? If we add up all of our paper clips, we have a total of 12 to choose from. And then we're going to multiply that times the probability of blue. How many blue are there? There's 5. And since we didn't do, we replaced our first choice, we still have a total of 12 paper clips to choose from. So the probability of red and blue, we're going to take 3/12 times 5/12. And we just multiply those two probabilities together. 3 times 5 is 15. 12 times 12 is 144. I'm pretty sure I can take out a factor there, right? Divide, can I? Or 122. I meant to say 122 down there. Oops. That's what, 15 over 122. 12 times 12 is 144. I did have that correct. So can we take anything out of, can we divide anything out? Can we simplify that fraction? I think we can divide each by a 3, right? Divide each by a 3. When we take 15 divided by 3, we get 5. And when we take 144 and divide that by 3, we get 48. So we can reduce that fraction. Another thing we could have done is just reduce this 3/12 before we multiplied. I know 3/12 simplifies to 1/4, and then it would have been easier to just get that 5/48. So if you can simplify before, sometimes that's the better way to go about doing it. And that would be our final probability, would be 5/48. We'll go ahead and leave this as a fraction. Remember, we could put it as a decimal and a percentage, but let's just leave that as a fraction. So that's how we find the probability of independent events. It's pretty straightforward. Find the probability of each event occurring on their own and then multiply those two together. Let's go to dependent events. I want to go to dependent events. So dependent events, and how do we find the probability of dependent events? Remember, that happens when we've got an event that is affected by another event. The events are then said to be dependent. So if we're talking about events A and B again, and they are dependent events, and we want to find the probability of both events occurring, then the probability of both events occurring is going to be the product of the probability of the first event and the probability of the second event occurring once the first event has occurred. So now we've got some special notation. So let's look down here. Focus your attention down here. Our notation is going to look a little different when we find the probability of dependent events versus what we did for finding the probability of independent events. So we're still dealing with events A and B. So to find the probability of both events occurring, if they're dependent, is first we're going to find the probability of event A, written just like this, probability, or capital P, parentheses A. Now we want to multiply that times the probability of event B once A has occurred, because A has affected B. So we write the event of B occurring once A has occurred like this. Look down here. Capital P, and then parentheses B with this line A. And what that means is right here, event B once A has occurred. So make sure we understand how to correctly write the notation and that you understand this. So go ahead and write this down in your math notebook right now, that if you were to see capital P and then in parentheses B with the line A, that means event B once A has occurred. And then you multiply those two together. So let's go ahead and apply this to an example, because we know things always make a lot more sense once we see it in an example. So we've got this same drawer that we just found the independent probability of. Same drawer. We've got 3 red paper clips, 4 green, and 5 blue paper clips. One paper clip is taken out of the drawer and then it's not replaced. And then we reach in and choose another paper clip. So we want to find the probability that the first paper clip is red and the second paper clip is blue. So how do we do that? Let's go ahead and write down our notation here. So we want to find the probability of choosing red and blue. So because we are not replacing a second paper clip, the second event is going to be affected by the first event. So we would write this as the probability of choosing red, and then we're going to multiply it times the probability of choosing blue once we've chosen red, or after we've chosen that red. All right, so what is the probability of choosing red? Well, we already did this, right? Red is 3 out of 12. And then what is the probability of choosing blue? Well, blue, how many blue are there? There's 5, but how many are we choosing from now? Because we're holding on to that first marble. So now there's only 11 to choose from. So see how that's a little different in this example? And then we're gonna multiply together. Again, if I want to reduce and say that I've really got 1 out of 4, I'm reducing. I know I can divide a 3 out of that and to get 1 out of 4 and multiply it times 5 out of 11. And what do I get? 1 times 5 is 5. 4 times 11 is 44. So 5 out of 44 is our probability here with our dependent event. So again, make sure that you are noting the difference between independent and dependent events. So let's summarize what we've talked about so far. So I'm going to go on the next slide, so if you need more time, go ahead and click pause. So summary, probability in a nutshell is a number of ways something can happen divided by the total number of outcomes. That's the most generic way we can summarize what probability is. But now when we start talking about more specific types of probability, we can say that dependent events, such as when you take something out of a bag and hold on to it, you're not replacing it, dependent events are affected by the previous events. Whereas independent events are not affected by the previous events. And we can calculate the probability of 2 or more independent events by multiplying. Same with dependent events. We find the probability of 2 or more events by multiplying those together. We are to the key phrase assignment. Let me put that up. So in probability, there's a lot of notation that is used to show different types of probability that we're looking for. And it's really important that we understand what the notation means. I went over what this notation means in the weekly recording. So I want you to tell me, what does P parentheses B line A, what does that mean? What does that mean? What does that notation mean? What are we looking for? What type of probability? So answer that question for the key phrase question. You'll get your points for watching this recording. Have a great rest of your week, and as always, let me know if you have any questions or you need help with anything.